19, find each of the following. A, vertex. We can spot the vertex right there. We've got the points. The coordinates are 1, -9. The solutions are the points where it crosses the x-axis, there and there. So you'd say the solutions are -2 and +4. Max or min value, well, this is the bottom of the parabola right here, okay? So we would say that's a minimum. So it's a minimum, which equals -9. The minimum value is -9. Domain. The domain is what you would get. It's like if you squashed everything, if you only looked at the x value. So I like to think of it as taking the parabola and squashing it flat onto the x-axis. If you can squash that flat onto the x-axis, you're going to notice that it covers everything. And so if everything is covered, we would say all real numbers. Now the range is what you would get if you squashed it onto the y-axis. So if you completely squash that thing flat onto the y-axis, it's only going to go from -9 up. And so we would say something like y is greater than -9, or you could say something like -9 to infinity if you wanted to. Either way. Use technology to help answer these questions. All right, you guys liked these because you got to use websites and they did all the work for you. So check it out here. Hang on. Okay, so what we did, we went to Goldadder, and let's see, we're going to do a quadratic regression, right? Okay, 20, find a quadratic model for the data. So yeah, we did a quadratic regression. We had to enter in all those points. So how it works is you enter in all your x numbers, -2, -1. Okay. We had -2, comma, -1, comma, 1, comma, 3, and 5. And your y values, look back at your y values, -74, +47, enter in those y values. -74, +47, 5, -21, and -31. Okay, go back and look. We entered our x numbers, we entered our y numbers, and really that's pretty much it. Okay. So this answer is pretty complicated. I don't think it normally will be this complicated, but it doesn't matter because the computer did all the work for us, right? So it's -4.455. All right, so there we go. Y equals -4.455 x squared plus 12.332 x plus 6.043. All right, it's a pretty messy answer, but that's fine. The computer did it. Now we want to take this and copy it over to Desmos. So I want to find the vertex of this thing, so let's again let Desmos do all the heavy lifting. And okay, so we're looking at this parabola here. You can zoom around until you can find the vertex, and that looks like that's what would be the vertex, 1.384, comma, 14.577. $14.577. Again, I didn't mean to make it that complicated. It won't be that complicated on the test. All right. Again, it doesn't matter because the computer did all the work. Number 21, a rocket launch can be modeled by this equation. So we want to find some different things out about that flight. So we're just going to use Desmos again, negative 16t squared plus 160t. So let's type that in. $160t. All right, so need to find the top. Whoa. There it is. Okay, so you know what I can do is if I click on the wrench over at the right, I know you can't see it, but if I click on the wrench, I can change the settings. I'm going to change my x-axis. Actually, I'm going to change my y-axis to go from -5 to 415. And yeah, that's pretty good. Okay, so what were the questions? Find the maximum height of the rocket. Well, that's this point up here, the vertex. It looks like y is 400, that's the maximum height. So since we're in feet, that's 400 feet. How long is the rocket in the air? So if you look at this, here's where it's fired, right here at time 0. And then it flies up, comes down, and it hits at 10 seconds. So how long is this thing in the air? Looks like it's in the air for 10 seconds. How high is the rocket? At t equals 2 seconds. Okay, so at time equals 2 seconds, it's going to be around in here. Okay, you can, if you're having a hard time finding it, it's 256. If you're having a hard time finding it, you can always say x equals 2 and find that intersection point. That's a little bit easier to find. But it looks like it's 256 feet high at time equals 2 seconds. And that's it.